Good day, house. Today we'll be looking at interpolation. Interpolation is quite an interesting topic. Now, when you're asked to plot a graph, you're normally given a table of your x and y. Now here can be, let's say, 0, 1, 2, and 3. And you can have values to be for your y to be 3, 4, 5, and 6. So let's just assume that maybe this wasn't given, and let's say 3 and 4 was given, something like this. If something like this is to ever exist, actually it does exist. Okay, 8. So this is how our table will look like. If you're asked to plot a graph, this is normally how your table used to look like. Now, in some cases, they will tell you what is the value of y when x is 2. You can see in this example I'm giving now, there is no 2. So they can ask you what's the value of y when x is 2, or even when x is even minus 1. So in that situation, it requires you to go back to your graph, find where the look at your graph line, start tracing your 2 to your graph and rest of them to get your values. But that will require you to first of all draw the graph. So let's plot this graph. We'll be having something like here. Let's have 1, 2, 3, and 4. While here we'll be having 1, 2, 3, 4, 5, 6, 7, and 8. So if I have to plot this graph now, we'll be having that for our 0, where x is 0, this is our x, and this is our y-axis. So when x is 0, our y is what? 3. So we're having 1 point here. Where x is 0, where x is 1, y is what? 4. So if we trace this, this is another point. Where x is 3, y is what? 7. This is another point. Where x is 4, y is what? 8. So at the end of the day, you will join your line, and they might ask you what is the value of y where x is what? 2. You have to start tracing it. If this was a proper graph, it will be giving us a right answer. Then start tracing it to whatever value you want to trace it on this part. Whatever you trace, you assume that is your answer. But this will require you to draw. Now, interpolation can actually give you the value of 2, can give you the value of y when x is 2, even without you knowing how your graph looks like. That is interpolation for you. It can give you the value of 2, the value of y where x is what? 2, without you drawing the graph. So for interpolation, we normally have 4 ways of interpolating. We have 4 methods in interpolation. Now under this, we have the first one, which is what? Newton's forward method or interpolation. Second, we have Newton's backward interpolation. And third, we are having Lagrangian Lagrange's we are having Lagrange's method. Lagrange's method. And last and not least, the last and least, there's no other known method to me, binomial method. Now each of these methods are unique, and they are used in a special case. In some special cases that require that in some unique cases, each of them will have a particular place that if you apply them, they will do perfectly well. For Newton's forward and backward method, for these two, we use them when the difference between our given interval, our given values of x is known, is what? Equal. Is equal. We use it when the difference between the given value of what? X is what? Equal. Like for the example that I gave earlier, you having your x and your y, and there being your 0, 1, 3, and what? 4. As you can see, the distance between this and this is 1, but between this and this is what? 2. So we won't be using Newton forward or backward method here. But in a case where all these values we are kind of having equal interval, that means there's a 2 here. Then the distance between, or the interval between 0 and 1 will be 1. Interval between 1 and 2 will be 1. Between 2 and 3 will also be 1. And between 3 and 4, it will also be 1. Then in that case, that is when we will then use either Newton forward or backward. That is when we use them. Now, the reason why we also have a forward and a backward method is that our unknown value, maybe if you are asked to find, let me say 1.5, you're asked to find 1.5. If we're using this table, for instance, which have about five x values. So if we are asked to find the value of y when x is what? 1.5, we know that 1.5 will fall in between 1 and what? 2, in between this place. So at this point, what we'll be using is what? Newton's what? Forward interpolation method. Reason being that the 1.5 falls under the first half of your given values of what? X. What I mean by first half is that you have 0, 1, 2, 3, 4. Total, that is 1, 2, 3, 4, 5. This is 5 numbers here. The one at the center is what? 2. And 1.5 is falling in the front, in the first half of, is falling within the first half of this 5 value. So that is why we'll be using what? Newton's what? Forward Newton forward interpolation method. So for this place, the unknown variable should be within first half of table values. Why this is the opposite? The unknown variable will be within the second half, or the other part of the table values. So that's the difference between this. So let's say you are asked to get the value of y when x is what? 3.5. So 3.5 we know falls in between 3 and what? 4. So definitely we'll be making use of what? Of Newton what? Backward interpolation method. And you might ask, what if our value, maybe the number of x values given to us are even, and maybe you're asked to find the one at the center. In that case, either Newton forward or Newton backward method will work for you. What I mean is this. For instance, let's say this is how our table is. Here is 2, 4, and 6. And you're asked to find, let's say, 5. Definitely 5 will fall in between. No, sorry. You have to find 3, not 5. You have to find 3. Definitely your 3 will fall in between your 2 and your 4. So in this case, you can either use your Newton forward interpolation or your Newton what? Backward interpolation. Whatever method you use will work in this situation. Now, moving over to that of our Lagrange's method. For this, we use it when the distance are not what? Equal. It is the opposite of whatever these two is. So like for the first case that we made mention of, where we had something like 1, 3, and what? 4. So in this case, what we will be using is what? Lagrange's. We'll be using Lagrange's what? Method. So we'll use this when the difference between given values of x is not equal. So that's for your words, your Lagrange's. Now, for your binomial is a special case. This one is used when you are given the value of y to find x. So in maths, we normally represent our x as a what? Independent what? Variable. and y as our what? Dependent what? Variable. And this can either be called the what? Argument, while this is also called entry. So whatever you choose to call it. So whatever you are given a table and you're asked to fill it. Let's say for instance, let's say this is 0 and here is empty, here is empty, and they tell you here is 5, something of this nature. And maybe they gave you the values, let's say 8, 7, and 14. So in this case, what we use is what? Binomial method, because that's we want to fill in these empty columns. So it will kind of have to rely on the already known values to get what is here. So we use binomial method. We use binomial method when x is missing. X being the what? Independent variable. So that's all about interpolation method. In the next video, I will be dropping an example of each and every one of this method. Subscribe to the channel, like the video. If this little information was helpful, see you soon.